Let's see the next question in this exercise, question 12 to 7. We have been given a solid and that is comprising of right circular cone sitting on top of a hemisphere, and this combined solid is inserted in a cylindrical object, and we are supposed to find out how much will be the water capacity of this particular cylinder. So let's see the diagram really quick. We have this cylindrical outer object, and inside we have inserted a combinational solid, and this solid is made by, the bottom portion is made by hemisphere and the top portion is the cone, such that the radius of the hemisphere and the radius of the base of the cone is exactly matching. Also, the radius of the combined solid, which is this hemisphere as well as the base of the cone, is precisely matching with the radius of the cylinder. And the dimensions are given such as the cylinder is 180 centimeters tall, cone is 120 centimeters tall, the radius of the base of the cone is 60, which is same as the radius of the hemisphere and radius of the cylinder. In order to calculate the water into this particular object, we have to simply consider the outer container, which is cylinder, and subtract the volume of this combined solid inserted inside. Volume of the water left, so the cavity left here, that will be volume of the outer object, which is cylinder, minus volume of the cone minus volume of the hemisphere. So that is the cavity left in this object, and that is the place where water can actually enter. Volume of the cylinder, we know the formula pi r square h. I'm writing h as uppercase so that we will not get confused with height of the cone. Uppercase H, capital H is the height of the cylinder. R is the radius, and this R I can use throughout same because the radius of all three objects is exactly identical. Minus volume of the cone is 1/3 of pi r square h, and volume of hemisphere, well, full sphere is 4/3 pi r cube, and hemisphere will be half of that, so that will be 2/3 pi r cube. We can take pi r square common, and I will go ahead and I will take 1/3 also common, even though 1/3 does not appear here. In order to compensate for that, I will multiply this by 3. So indirectly I am saying this is 1/3 of 3, which is same as 1. So once you take 1/3 common from the first term, you have 3h. From where this 3 is coming? 1/3 times 3 is same as 1. So eventually it balances out. If you are not comfortable taking 1/3 also outside, leave it inside, absolutely no problem. If you take 1/3 common and pi r square common, you will have h remaining, and if you take 1/3 common and pi r square common, you will have 2 remaining, and then 1 power of r will still remain. So in the bracket you will have 3h minus h minus 2r. Now let's substitute the values. Pi is 22/7. R square, R is given as radius as 60 square, 3 times capital H is 180, minus 120 minus twice of 60. So if you do the calculations, 3 times 180 is 540, minus 120 is 440, 420, and then again minus 120 will be 300. Now let us see what can we cancel. This 3 can be cancelled with 300, and only 100 remains, and nothing else can be cancelled. So we'll try to multiply this and divide by 7. The answer comes out to be centimeter cube, because this is volume. Now this is a very large number. If you want to convert that into meter cube, remember 1 meter is equal to 100 centimeter. So 1 meter is 10 to the power 2 centimeter. So 1 meter cube is 10 to the power 2 times 10 to the power 2 times 10 to the power 2. That is 10 to the power 6 centimeter cube. So once I want to convert this centimeter cube into meter cube, I have to shift this decimal point towards left 6 places. So 3 places and 3 more places. So eventually, if you want, now, if you want to keep this as it is, that's fine. Uh, in the question, they have not mentioned whether they want it in centimeter cube, or liter, or milliliter, or meter cube. Just I'm showing you one extra step. This is how the answer is given at the end of the book. So the decimal point has to be shifted 6 places towards left. So from here, 3 places and 3 places. So it will come between these two ones, 1.1. So answer will be 1.1 and something. So that would be 1.131 meter cube, and that would be your final answer.